In this video, what we're going to do is we are going to fix our Chrome developer tools so that we can do JavaScript debugging inside of Chrome, as well as hook Visual Studio Code up with our Chrome developer tools so that we can perform actual debugging tasks within Visual Studio Code itself. So this is a really important thing that a lot of people miss when they are putting together their build step, the ability to do line-by-line debugging with their application. And because I want this to be fairly complete, I want to tackle that issue right now. Now there's a slight issue with how I'm producing source maps, which is going to confuse the Chrome developer tools. So I first want to get that resolved. And so as far as debugging being available, it'll be fantastic for me off camera to make sure that, things are working. And it'll also allow me to show you guys execution of code line by line. But again, it's so easy to set up debugging support with Visual Studio Code and with Chrome that I figure we might as well just do that on video. But right now, things are not set up properly. If I come over here to, let's open up our source client component app.js, and let's change this up just a little bit so that there's some interactivity, something we want to debug. So I'm going to return a section in JSX, and the section will have our hello world h1, and then we'll also have a button, and the button will be, I don't know, I am button, please click. And for the buttons on click handler, I will say on click equals this dot underscore click bind this. And then I'll add the underscore click method, and he will simply console log out stuff. I don't care. Hit Control S, and then I'm going to have to reload Chrome for this. And the reason I got to reload Chrome is because it needs to pick up whatever new source maps were available from the module that was loaded. And then if I hit F12 and come over here to console, you'll see that we get our hey there, and he's pointing to app.js line 7, which is correct, actually, but it's not going to quite work the way we expect it to. So if I click I am button please click, look at what line number it's now pointing to. Index at line 20. And if I click on that, I will get this empty file with the word undefined up here. So clearly there's something a little bit messed up going on with our ability to debug. If I look at our styles, like if I click on this H1 that we styled red, it will allow me to click on client CSS, SCSS, and actually show me what line that is, almost what line that is, but it's still a little confused because it's pointing to line 4 instead of line 7. So it seems that we have a bit of a source map problem. Furthermore, if I actually open up Webpack, go into source client, go into components app.js, look how only lines 1 through 7 I can click on. I can't click on a breakpoint for this click handler. It is grayed out. So clearly there is a source map issue. Our source maps are all messed up. With Webpack, there are multiple ways we can generate source maps. And if you open up the documentation, you can find them out under the docs configuration.html, and you can take a look at DevTool. And this will give you all your different options. Eval, cheap eval source map, cheap module eval source map, cheap module source map, eval source map, and source map. So it'll tell you if it's supported in production. It'll give you an initial build speed and a rebuild speed, and then it'll give you its quality. So for example, the cheap eval source map and cheap source maps only give lines for the transformed code, meaning the transformed code that's already been spat out by Babel. Whereas our cheap module eval source map and cheap module source map give us lines only for the original source. And then for eval source map and source map, they give original source. The difference between the eval options and the non-eval options is how the source maps are generated. So if I come over, or how they're integrated in with the file. If I actually open up my page source and click on build app.js, and I scroll down to where the source map URL is, all the way at the bottom, it's pointing to a source mapping URL of app.js.map. So this entire file is represented in this source map file. I'm going to view source on this so my JSON plugin doesn't get a hold of it. And the source map file is just a JSON file which goes through and maps each individual line of source code with our original source code. Now, the problem with that, the problem with not using the eval style, is anytime any line of code inside of the original app.js changes, even if it's just one line of code in my style sheet, the entire source map has to be regenerated because the source mapping is being applied to this entire built file. So what I'm going to do is I'm going to switch our source map support over to a version that's going to work properly in Chrome and be understood by Chrome, but most importantly, it will give us line and column information, and it'll use Eval. So we'll be able to figure out or see how using the Eval option changes our source map. So I'm going to change this dev tool to eval-source-map. Now the eval source map will point not to the transformed code, but to the original source code. So my original source code that I want to get line by line information about, but it'll use the eval option. So watch what happens when I come down here and I hit Control-C and terminate this batch job and then do gulp dev again. Because remember, I changed Webpack docconfig.js. Make sure that you restart your server and your Webpack dev server and all that fun stuff. Then I'm going to come over here to app.js and I'm going to reload it. And when I reload it, you'll notice a huge difference with how every single individual module is included. Now, every single module is wrapped in an eval statement. But most interestingly, the source maps are added right at the eval statements. Eval statements can include source maps. So as you see, the source maps is directly added to the eval. And the reason why that is significant is now each individual module is self-contained. Meaning if I change one module, like let's say this module, I don't even know what module this is, but if I change this one module at all, just change a line of code, the only source map that needs to be regenerated is the one that's appended right here and not the entirety of the file. So that's what the eval option does. But as far as changing it from the module source map to, or cheap module source map into normal source maps, if I come back over here and reload, notice how my hey there is now app.js, the proper line. And if I come over here to our console and I hit I am button please click, oh, that's the breakpoint that's been left over from my original testing. Let's refresh, do that again. If I go back to the console and say I am button please click, it says stuff, but now notice that it's doing app.js and this particular line and this particular file, this particular column, and it's now pointing to the actual original source code being rendered out. And now, notice that I can now add breakpoints to the entirety of the file. Well, not the entirety. I can't obviously add a breakpoint to these empty lines, but I can add a breakpoint to this click. And now if I click the button, it is now in our debugger. And we can investigate our locals, we can investigate our call stack and see how, learn how React deals with events internally. We can add watches, we can execute code, we can do a lot of stuff. And that will allow us to do proper debugging. With that out of the way, let's go ahead and integrate this with Visual Studio Code. So if we come over here to our extensions, I already have this guy installed, Debugger for Chrome, but you'll want to go ahead and go to extensions, search for Debugger for Chrome, and then install this extension, Debugger from Chrome, made by Microsoft. Once you have it installed, you will want to create a launch configuration file in the .vs code directory. However, there's a shortcut. We can try to run this, we can try to enter debugging with Visual Studio Code, and if it doesn't detect a launch.json file, it'll generate it for us based off of which debugger we select. So go ahead and hit F5 and select, where are you? Chrome. Remember to restart Visual Studio Code every time you update or install an extension, by the way. Now what that did is that generated a launch.json file under .vs code. I'm not going to worry about this default launch Chrome against localhost with source maps. I'm actually going to remove that configuration. So if you weren't able to automatically generate this launch.json file for Visual Studio Code, go ahead and copy what you see here on the screen. Now, the next thing we have to do, and this is actually specified in the extension itself, if we go back to our extensions and we click on Debugger for Chrome, it will tell us all the way somewhere. I probably already scrolled past it, didn't I? it'll tell us right here what we have to do to Chrome itself to open up its debugger for external applications to work with. And so on Windows, what we do is we go to our Chrome icon, right-click Google Chrome, go to Properties, and simply at the end of our target, but after the final double quote, the double quotes contain the full path to the executable. But after the double quotes, we put in -- remote -debugging -port equals the default in this case 9222. And you can see that represented down here inside the details for the Chrome debugger. And it also gives you options for OS X as well as Linux. So make sure you do that, and make sure you completely close Chrome by closing all of your active tabs and then checking your task manager to make sure all instances of any background process for Chrome are stopped. Alternatively, you can restart your computer. That'll work as well. And then relaunch Chrome. And then when you relaunch Chrome, you will then be able to attach a debugger. There's actually one thing I totally forgot about in launch.json. And that is I want to go ahead and restrict this to a particular URL. So I'm going to come down here to the bottom, add a URL property, and put in http://localhost:3000 / And what this will do is this will only attach it to tabs that are open to this pattern, which is the pattern that will match our application because we're serving it on port 3000. So with that all out of the way, there's one more caveat. So if I open up Chrome with the development tools open, and I come back to Visual Studio Code, and I try to hit F5 to launch the debugger, it won't actually launch. It'll show us an error after a few seconds. And the error that it'll show us is telling us that we cannot attach a debugger. Here's the error. We cannot attach a debugger if we have the Chrome development tools open within the Chrome instance. So make sure you have those closed, and then try again by hitting F5. Now we are attached, which means we will receive console output, and we will also be able to put breakpoints into our code. So if I come back to app.js, well, let's look at the console output first. If I say I am button, click here. I hid my console, didn't I? Debug, where's my console? Focus debug console, here we go. Here's our debug console. So I just did that by hitting Control-Shift to P, and typing in focus debug console, and that'll open up our debug console for us. And that'll show us our stuff messages as I click this. So it's the same thing as the console window in Chrome. I can even do arbitrary logic here. I can say like document.getElementById mount and hit enter, and it'll show me my actual HTML element div mount. But we should also be able to set breakpoints. So over here on click, I should be able to set a breakpoint, and by it turning that bright red color, that will indicate that the breakpoint was successfully set. So now when I click on that button, notice how it says paused in Visual Studio Code. The entire application becomes paused, and I'm able to do all the debuggy things that you would expect to be able to do, such as look at my call stack and click through my call stack and see how React works underneath the hood. We also have our breakpoints, obviously. We can do our watches, where we can watch particular variables. We can step over, step out of, step into, just like usual. I can open up my debug console. And I should be able to type in this, and it gives us our app container class. So you notice the debug console is now in the current context of this function that we're broken into. And then the only shortcut keys you need to remember are F5, F10, F11, and Shift F11. So it's the same thing as Visual Studio. So if I go ahead and do F10, I can step through. See, when I hit F10, the stuff appeared because it executed this line. And I can actually step through and watch all of this code execute behind the scenes in React. I can even hover over variables and inspect them, just like you would expect a normal debugger would allow you to do. So it's a fantastic way to learn. It's a fantastic way to debug your applications and so on. And now I can just hit F5. And by that's the continue button. By hitting continue, the application is now started back up again. So yeah, basically all we had to do in this video is we had to change our source map type to eval source map, which is going to be slightly slower than our cheap eval source map, but that's okay. It's not going to be significant in the application we're building in this series. And then after I did that, I installed the Visual Studio Code Chrome Debugger extension, created a launch.json file with these parameters, and told Chrome to allow remote debugging on a particular port, and that was it. Now I have a powerful debugger built into my workflow that I'm going to be able to use both on and off video. Anyway, I just wanted to show that to you guys. And with that, we will see you in the next video.